Thanks, welcome back everyone. And I wonder, should I dance when that music starts like that? It kind of makes me want to dance. So welcome to Tips, Tricks, and Techniques for Building great Silverlight 5 or Silverlight apps. I have Silverlight 5 on the brain, Silverlight apps. And to start things off, I wanted to give you a URL. You see it in Notepad at the top of the screen. I'll be doing a few slides in this session and lots of demos. We're going to write a lot of code. I thought you might want a copy of the demos that I show and the code that I write. You can go to that URL at your convenience and download a zip file. It's about 20 megabytes in all, maybe slightly less. And it does contain a copy of everything that I'll be doing here, plus everything that I'm doing that I did in yesterday's sessions. And there's actually one talk I'm doing in the Netherlands later this week that I'm not doing here, one on Silverlight versus HTML5. This zip file contains the samples for that as well, if you're curious. So I'll try to remember to put this URL back up at the end of the session in case you haven't had a chance to write it down. But I have a lot to cover, so let's just get right into it. So I want to talk about some advanced techniques for building better Silverlight applications. A lot of what I've built into this session comes from my experiences working inside and outside of Microsoft, working with real customers who are building Silverlight solutions, seeing the kinds of problems that they've had, and more often seeing how they do things wrong rather than correctly. So a lot of this session is about doing things dynamically in Silverlight that are normally done statically. And the first thing I want to talk about is how to do dynamic loading of assemblies. Because if there's one thing that I hate to see in a Silverlight application, it's a large zap file. Some of you may have experienced firsthand that when a zap file gets too large, Silverlight can't load it. It throws an out-of-memory exception. When people ask me why that is, my question to them is, why are you deploying a zap file that large? In fact, one of the things that we as developers should strive to do is keep the zap files as small as possible so that those applications that we're writing and deploying load and start up as quickly as possible in a user's browser. Unfortunately, knowing how to factor a zap file, how to separate it into separate zaps, how to leave resources like assemblies and other things that normally live inside the zap outside the zap is sometimes a bit of a black art in Silverlight. So I want to show you, for starters, how to do dynamic assembly loading. Now, I'm going to do a demo that'll take me 10 or 15 minutes. We're going to build something from scratch so you can see this come together. But what I'm going to do is essentially this. I'm going to take an assembly that my application relies on, and rather than embed it in my zap file, I'm going to stick it on the server where I can download it asynchronously with the web client. Once I've pulled it down, I'll use a little API in Silverlight called assemblypart.load to load that assembly into the app domain. Once I've done that, it can be used just as if it had been packaged in the zap file and loaded into the app domain automatically by Silverlight. Now, as you're going to see, it's relatively simple to do, but there are also a couple of gotchas that you have to be aware of them. One of them having to do with the JIT compiler. Rather than spoil the surprise, let me just go right into the code, and we'll talk about that more when we run into it. So I'm going to crank up Visual Studio here and create a new Silverlight project. And no, we don't want a phone application. We will create a Silverlight application. Let's call this Load Demo. I think I called it Assembly Load Demo in the pre-built version in the slides. And yes, we'll let Visual Studio go off and do its thing. Now, we're going to start off by doing something very, very simple. I want to create a UI that consists of a calendar control. But as you may know, a calendar control doesn't live in the core Silverlight runtime. Instead, it lives in an external assembly named system.windows.controls.dll. So before I can do something as simple as declare that calendar control in my app, I do need to add a reference to that assembly. So let's do that. We'll find system.windows.controls right here. Then, in order to declare that calendar control in main.page.xaml, I'll need to add a custom XML namespace prefix to help out the XAML parser. So let's take care of that here real quickly. Doesn't really matter what we call this. I need ns, and let's call it controls, since we're going to have it refer to system.windows.controls. So let's go find that in here and let Visual Studio and IntelliSense help us out just a bit in adding that in, and that's the one that we want. Now, we should be able to declare a calendar control in this application. So let's give it a try. IntelliSense seems to know what I'm doing. That's always a good sign. We'll need to give that calendar a width and a height. Let's say 300. Maybe we'll do the same for height also. So right now, if I do nothing else, if I just run this thing, what I would expect to see is a calendar control in main page. Let's see if that's the case. There you go. So far, so good. Now, I want to do something a little bit different. I'm going to get rid of that calendar control, and I'm going to replace it with a button control. And we'll give it a width and a height to try to make it look somewhat good. How about 150 and maybe 100? And for the content property on the button, I'm going to write create calendar. Because what we're going to do when this button is clicked is create a calendar control dynamically. Now we'll need a click event handler. To do that, we'll let Visual Studio write it for us. Then we'll jump over to the code behind, and we'll add some code to that click handler. Let's take care of that. So here's the click handler, and the very first thing I'm going to do when it fires is remove that button from the visual tree. Once the calendar control is loaded, no need for that button to be there anymore. We should be able to do that pretty simply since it's a child of layout root. I'll go into layout root's children property, and I'll do a remove. I should be able then to pass in sender, but to satisfy the compiler, I'm going to have to cast that to a framework element or a UI element. So looks like I tried the Dutch spelling there, huh? So hopefully that'll work in getting the button control gone. Now let's create a calendar control dynamically, and let's add it to that layout root grid so that the user will see it. So I'll do calendar, cal equals new calendar, like that. We'll need to set a width and height on it, I guess. So let's do exactly the same thing in code here that we did in XAML a few moments ago. And finally, we'll need to add that to the XAML DOM so that it can be seen. This time I'll do an add instead of a remove, and I'll pass in that calendar control. If that works, I should now be able to click the button, and we should see a calendar control appear. So far, so good. Now, obviously, this is a very simple application. But I would submit to you that even in this simple application, we're being very wasteful at this point. Because depending on how the user interacts with the app, that is, if they never click that button, we're forcing that user to download a copy of system.windows.controls.dll. It's there, and it's embedded in the zap file. In fact, if we go over to the zap file right now, we should be able to see that there is a copy of system.windows.controls.dll in there. And indeed, here it is right here. Let's be a little bit smarter about this. Let's suppose instead of a simple application like this, it's a much larger, more sophisticated app that may have dependencies on dozens of assemblies that may or may not need to be loaded into the application domain, depending on how the user interacts with the application. Is there something that we could do about this? Well, there is. One thing we could do is get rid of that reference to system.windows.controls.dll. That would certainly get it out of the zap file, but the compiler is probably not going to be very happy, right? Because it's then going to have no idea what the calendar type is. But I could do this. I'm going to find system.windows.controls in my references. I'm going to go down here to the properties window, and I'm going to change its copy local property from true to false. Now, if I rebuild at this point, an interesting thing happens. Number one, the compiler is happy. It's as if system.windows.controls.dll were still there. But if I look in the zap file, I'll find that it's not there. Our zap file is much smaller now because that assembly has been removed. So what's going to happen if I run this thing? Does the fact that the compiler is happy now mean that the runtime is going to be happy as well? Well, let's find out. So far, so good. I launch the application. I click the Create Calendar button, and boom, we get a big unhandled exception. Not surprising. If you look at the error message, it says that it couldn't find system.windows.controls.dll. And that's probably not surprising because the only place Silverlight knows to look for that DLL is in the zap file. It wasn't there. So when we tried to execute that line of code that creates the calendar control, Core CLR threw up his hands and said, I can't find the assembly where this thing is implemented, therefore I cannot do what you had asked. So now we're going to get a little bit more clever. When that button is clicked, we're going to do an asynchronous download using a web client of that assembly, and we're going to use assembly_part.load to load it into the app domain. So let's go up to mainpage.xaml here, and let's do a little bit of surgery on this button click handler. So I'll push this down a bit. I'll end up moving that in a moment. We'll still remove the button from the XAML DOM, but let's now fire up a web client like this. Not like that. And we'll call it WC. We'll new up web client. And we'll need to register a handler for the event that's going to fire when the async download completes. That will be right here, open read completed. I'll hit tab a couple of times and let Visual Studio write an empty event handler for me. And once I have that wired up, then I'll do this. I'll actually put the call out on the wire by calling open read async. And I'll need to pass in a new URI here telling the runtime where it can go to find it. I am going to have to post a copy of this. What I'll do is put in a client bin so that the relative URI for the assembly that we're going to download is system.windows.controls.dll, like that. I'll also have to pass in a URI kind telling the runtime that that is indeed a relative URI. And now, before we do anything else, let's go over to our server project, and into client bin, let's add a copy, a reference copy of that assembly that can be downloaded. So I should be able to find that in my program files, Microsoft SDKs folder, if I dig down deeply enough. Where are you, Microsoft? Ah, there we are, right there. Silverlight, version 5. Libraries, client side, and I should find that reference copy that I'm looking for right here. Now, what else are we going to do? Well, one thing I'm going to do is once I've launched that async request and it completes, I'm going to move the code that creates the calendar control down into that completion handler. But I also need to do a little bit of work before I attempt to create that calendar control. Specifically, I need to load the assembly into the app domain. I can do that pretty easily by doing this. I'll new up an assembly part object, and then I'll simply call part.load. And what it wants here is a stream. I can get a stream containing that downloaded assembly from e.result. And in fact, just to be judicious here, or just to be defensive, I should probably do this. Let's make sure that the download succeeded. So I'll check to make sure that that error property in the open read completed event args is null. Because if it's not, that means something went wrong. We hope to see it null. So let's see here. Let me move this down here, add a closing curly brace. And just for good measure, if that error property is not null, that means it contains a reference to an exception object. We'll make that painfully apparent by displaying that error message in a message box. So I should be able to write e.error.message like this. Hopefully we won't see that. Now, to sum up what we've done here, now if and only if the button is clicked, we go download a copy of system.windows.controls.dll. Once the async download completes, we load it into the app domain. We then attempt to create the calendar control. Looks pretty good. Let's see if it works. So once more, the button comes up. I click the button, and we see a calendar control. Was no one going to tell me that we don't really see a calendar control? We don't see a calendar control. What happened here? An exception was thrown again, one that we failed to handle. And guess what? If you look at the error message, it's still complaining that it can't find system.windows.controls.dll. But how could that be, given that we downloaded it, we loaded it into the app domain? What you're seeing here is one of the best examples I've ever come across of why, even if you're a Silverlight developer, it pays to understand the .NET framework. Specifically, it pays to understand core CLR, which comes from the same source code base that the big CLR does and has the exact same JIT compiler as the big CLR. Let me tell you what's happening here. And there's an interesting little experiment that you could try. You may see this happen and think, you know what? I need to see that call to assembly part.load execute. I'm going to put a breakpoint in that open read completed event handler. If you did that, guess what? That breakpoint would never be hit. It turns out that method is never being called. The open read completed event handler is never being called. Why? Because the JIT compiler in Core CLR works exactly the same way as the JIT compiler in the big .NET framework. Think about this. Think as if you're a JIT compiler for just a moment. The first time a method is executed, it has to be compiled from IL into native machine code, obviously. So Core CLR passes this open read completed event handler off to the JIT compiler and says, compile this for me. One of the things that the JIT compiler has to do to compile that into native machine code is resolve all the type references inside it. So it looks inside that method, it sees a reference to something called calendar, and then finds that there is no assembly already in the app domain that it can use to reference that type. Therefore, this exception that you're seeing right here is being thrown by the JIT compiler before the method ever executes. It's a chicken and egg problem. Our code that loads the assembly isn't getting a chance to execute because the JIT compiler can't compile the method to begin with. Now, there's an obvious solution to this, but it's only a partial solution. Let me explain what I mean. What I need to do here to work around the JIT compiler is get this calendar reference out of the method that loads the assembly into the app domain. So what we're going to do is create a little helper method here. We'll just have it return void. Don't need that. And we'll call it create cal. And what I'll do is simply move this code right here that creates the calendar control down into this method right here. Then we'll call create cal right here. Do you see what I've done? Because create cal returns void, not calendar. Now the JIT compiler is going to be fine with that method, so it's going to give me a chance to execute the code that loads the assembly into the app domain. However, if you deployed the code like this, you've deployed a buggy application. In fact, if I ran this right now, it would probably work, but it's not guaranteed to work. Why? Because the JIT compiler reserves the right to inline short methods when it sees fit. Create cal is a short method. It's 3 lines long. And it is possible that a JIT compiler might decide to inline it. It's also possible it might decide to inline it here, but not inline it on a Macintosh or on some other processor. So, in order for this code to be 100% robust, we must make sure that the JIT compiler will never attempt to inline this short method right here. Let me add that missing curly brace. How do we do that? With this right here. I'm going to add another using statement, this one for system.runtime. See if IntelliSense will help me out to make sure I remember it right. Not rim time, but runtime. Oh, no wonder. Now I can do a .compiler services. And now I can walk back down to this method here, and I can slap a magic attribute on it. That magic attribute is method impl, and I'll need to pass in a certain method impl options here. That method impl options will be no inlining, except why isn't that showing up there in IntelliSense? We'll find out. Method impl options, let's see if that'll build. Nope, it doesn't like something about it. Is it complaining about, no, it says one succeeded, one error. Let's see here. Missing a closing parent somewhere. Oh, you know what? I know what it is. That should have been dot. There we go. Now it's going to run. But let's see if it actually works. This time I click the button. The button goes away. I download the assembly, load it into the app domain, and now we can clearly see that it has been loaded because the calendar control appears. So, this is one way to factor your applications, to reduce the size of your zaps. Take all those dependent assemblies, especially ones that you may or may not need, depending on how the user interacts with the app, and download them once the app is started. Keep them out of the zap so that the application starts up just as quickly as possible. Now, let me show you something else, and I won't build this live. because it would take a while to do it. But I want to call your attention to a related project that's already in the zip file whose URL I gave you earlier. So this one is called Assembly Loader Service Demo. And when you run it, it looks a whole lot like what we just built on the outside, but it does something a little bit differently and very important. So when I run it, once more I see a button. Once more, when I click the button, an assembly is downloaded, loaded into the app domain, and then I create a type from it. Here's what's different about this one. Rather than wait until the user clicks the button to download that assembly that we might need later on, it might make more sense when the application starts up to just go ahead and initiate one or more asynchronous downloads of all the assemblies and perhaps other assets that our application might need. And that's exactly what this one is doing. And to make that really easy to do, I built an application service, which you can just borrow. You can take and plug it into your code if you want to, that takes responsibility for doing the downloads in the background and for loading the downloaded assemblies into the app domain. Now, what is an application service? If you haven't heard of that before, back in Silverlight 3, the Silverlight team very quietly introduced a new interface called iApplication Service. It's not used a lot, but you can use it to build client-side Silverlight application services. What is a service? It is a component that begins running before the application starts up. And doesn't shut down until shortly after the application itself is shut down. The idea behind application services is that since their lifetime spans the lifetime of the applications that they serve, they're guaranteed to be there anytime that application is executing, including when the application first starts up and when it's shutting down. So what I've done here in this example, just to give you a quick look at it so you can look at it offline and decide whether you want to use it, is this. I built a class called Assembly Loader Service. If you look at the class, you'll see that it does implement the iApplication Service interface. That's happening right here. And then I built a really important public method into it named Load Assembly Async. When this method is called, it uses a web client to initiate a background download of an assembly. Once that download completes, my assembly loader service attempts to load the assembly into the app domain, and then it fires one of two events. It either fires an assembly loaded event telling you that the assembly was successfully downloaded and loaded into the app domain, or if something went wrong, it fires an assembly loaded error event. If you look over in mainpage.xaml.cs, I don't wait for a button click to go load that assembly. Instead, the moment the application starts up, I grab a reference to my running assembly loader service. I call its load assembly async method to load that DLL after wiring up handlers for the two events that it could fire once that's complete. And if there were other assemblies that I wanted to download and load into my app domain in the background, I could just call it load assembly async multiple times to make that happen. By the way, if you've never seen an assembly loader service before, let me show you where this instance that I'm grabbing a reference to here comes from. If you look over in app.xaml, in Silverlight 3 and higher, there is an application lifetime objects property on the application class. This is where we declare in XAML instances of the services, that is the classes we've written that implement the iApplication Service interface. So here's a nice self-contained background assembly loader that you can use. By the way, let me tell you something else that's kind of interesting about this assembly loader service that you'll see if you look at the source code. Many of you know that background threads in Silverlight are somewhat limited in scope. They're not allowed to access the visual tree, the XAML DOM, without throwing an invalid access exception. What a lot of developers don't realize is that there are other things that are illegal in Silverlight on background threads that have nothing to do with the UI. It turns out that in Silverlight today, if you call assemblyPart.load on a non-UI thread, it will throw an invalid access exception. So, one of the things I do inside my assembly loader service to make it completely robust is this. Because I don't know whether someone who's using my service is going to call it on a UI thread or a background thread, I check when that load assembly async method is called. And if I see that I've been called from a background thread, I marshal back to the UI thread where I am allowed to call assemblyPart.load. When you're building class libraries for Silverlight, you should consider doing the same thing, because when you build that class library and you deploy it, you have no control over how it's going to be called, whether it's going to be called on UI threads, background threads, or what have you. If you expose methods from that class library that do things that can only be done on the UI thread, if you will go the extra step of checking to see if you've been called on a UI thread and marshal back to it if you haven't, your colleagues and everyone who uses that class library is going to be happier with your efforts, because they won't be generating what seem to them to be unexplained exceptions. It will just work. Always a good thing to think about when you're building services, class libraries, etc. Now, enough about dynamic assembly loading. I want to go back to PowerPoint for just a moment and build on top of that, because while dynamic assembly loading is all fine and good, and it's relatively easy to do, more often what Silverlight developers would like to do is to be able to factor their application out into multiple ZAP files and download entire ZAPs when needed. One benefit to doing this is because a ZAP file is really a zip file. If you have compressible resources like text files, XML files or something that you want to package in the ZAP you download, well, packaging them as a ZAP rather than doing a raw text download should reduce the download size considerably. There are other reasons that we like to download ZAPs as well, but if we do that, we're going to have to figure out how to unpack a ZAP, to unzip it, to pull the contents out of it before we can use those resources. So here's what I'm going to do. In this next demo, I'm going to take that load demo app I built just a moment ago, and instead of downloading a raw assembly, we're going to download a ZAP containing that assembly. First thing we're going to have to do once the download is complete is unpack the ZAP, get that assembly out of it. So how do we do that? Well, it turns out Silverlight has a public API for extracting files from downloaded zips or ZAPs. It centers around a method named application.getResourceStream. This code here shows how I could take a downloaded ZAP, use application.getResourceStream to extract from it the application manifest. The reason that's important is that while Silverlight does have the ability to unpack a zip file, it does not have the ability, even internally, to enumerate the contents of a ZAP file. That's one reason that every ZAP file contains an application manifest. What we're going to do is use application.getResourceStream to pull the application manifest out. Then we're going to open the application manifest, parse the XML inside it, to build an enumerated list of all of the assemblies. Then, one by one, we will load those assemblies into the app domain using assemblypart.load. In fact, I'm going to just cut and paste some code from these slides to help me do that. So let me go ahead and grab this little bit right here, because it's the first bit that I'll need. All right. Now, let's go back to our load demo application right here. And now the goal is, instead of downloading this raw assembly, we want to download a ZAP file containing the assembly. So here's what I'm going to do for starters. I'm going to create another project in this solution. But rather than choose Silverlight class library as the project type, all that would do is generate a new assembly for me. I'm going to choose Silverlight application as the project type, because that will generate a ZAP file complete with an application manifest for me. So let's call this extra stuff. Wow, that was weird. Am I typing in Thai? There's some, well, I tell you what. Let's restart Visual Studio. There's some magic combination of keys, I think, that you press. I must have pressed them accidentally. I've actually seen that happen before. I don't read Thai very well, assuming that was Thai. So we're going to go back to English. Now let's try that again. So let's load demo again. I think I created that in my demos folder. I did. Okay, and there is that DLL again. And what we want to do is add a new project here to the solution. And this one we'll call extra stuff. And again, I'll be careful to make sure that Silverlight application is my project type. So here is our extra stuff project going in. And let's see, do we need a test page? No. We'll use the existing website. What this should do is make sure that when we build this solution, 2 zaps will now appear in our client bin folder in the ASP.NET project. Now, here is the new project. I don't need app.xaml because I'm really using this just as a container for an assembly. I don't need mainpage.xaml, so I'll get rid of that as well. But since I want it to contain a copy of system.windows.controls.dll, I'll need to add that reference here. So let's do that, and let's make sure that in that reference, the copy local property is set to true, which instructs Visual Studio to put a copy of that assembly into the zap. In fact, if we do nothing more right now than rebuild this thing, let's just make sure everything's good so far by verifying that 2 zap files now appear in client bin. You can see there's the application zap, and there's this auxiliary zap that we're using as a container for the assembly that we wish to download. And of course, if I wanted to include other assemblies in that zap file, I could just continue adding references to the project. They would be built in just as system.windows.controls.dll is being built in. Now, we need to do a little bit of work here because we no longer want to download system.windows.controls.dll. Instead, we're going to download extrastuff.zap. And we're going to have to do a little bit of work here as well because we're going to have to unpack the assembly from the zap before we do anything with it. So what I'm going to first do is paste in that code that I brought in from the slide. Now, it looks like I'll need a using statement here and for XML reader as well. And this is the actual stream that we've downloaded, so I'm going to pass in e.result. All I'm doing here is using application.getResourceStream to request app_manifest.xaml from the zap I've downloaded. Then I'm parsing the XML inside it to build a list of all of the assemblies that are listed there. Let's go back to PowerPoint for just a moment. I can expedite this further by doing a little cutting and pasting from this next slide as well. Once we've built that enumerated list, we'll need to actually load each of those assemblies into the app domain, which we can do with this little bit of code here. You can see me here calling assembly_part.load. Now, we'll need one more using statement. And the way this code is structured, obviously, it would work no matter how many assemblies are in that auxiliary zap file. If there are 10 of them in there, each one is going to be enumerated, each one is going to be loaded into the app domain. But the real proof of the pudding is, if we run it and if we press that button, do we still see a calendar control appear? Proof that system.windows.controls.dll has been loaded into the app domain. Clearly, the answer is yes. All right. Are you with me so far on this? Is this making sense? Because while we're talking about loading things dynamically, there's a lot more we can do in Silverlight. In fact, what about localization? Normally, we do localization, if we're doing ResX localization, that is, by building satellite assemblies containing localization resources. And while localization is not a difficult thing to do in Silverlight, most applications, I would argue, don't do it right. You know, there's something wrong with the camera because I have gray hair on the screen. Is my hair really that gray? Wow. It doesn't look that way when I look in a mirror. Maybe I need to buy a new mirror. I don't know. But let's apply what we've learned so far to localization. So I want to go back out to the slides here for just a moment to kind of set up what we're going to do, and then show you a couple of examples that I think you may find interesting. So for many Silverlight developers who are setting out to do localization, their first attempt usually parallels some guidelines and some samples put forth in MSDN. If you're doing ResX-based localization, you create ResX files containing your localization resources. At runtime, or at compile time rather, those ResXs get built into satellite assemblies, and those satellite assemblies get deposited in the application's zap file. And there is problem number one. It's not uncommon to have some fairly large satellite assemblies. Why make a user who is probably only going to want to see content in one language pay the price of downloading all those resource assemblies? Is there a way we could get those resource assemblies out of the zap, and then at runtime, once we've determined what language we want to display, load the corresponding satellite assembly then? Well, the answer is yes. In fact, since a satellite assembly is just an assembly, we can load it with assembly_part.load the same way we load system.windows.controls.dll. So we'll do a little bit of factoring. We'll separate out those resource assemblies. We'll download them when we need them and only if we need them. But while we're at it, we're going to tackle a couple of other problems as well. One of the things you're going to see me use in this next demo is a little class I built called Observable Resources. One of the things that bugs me about localization in Silverlight is that it's hard to do on-the-fly localization. That is, while a page is displayed to the user, you could attempt to change the culture used to display the content by creating a new culture info object and assigning it to the current thread. But until you refresh that page or refresh the data bindings or something in it, the user will not see the effect of that change to the current thread. I'm going to use this little class here named Observable Resources as a wrapper around the Resource Manager wrapper class that Visual Studio generates for me. And the reason I'm going to use it is this. Since today in Silverlight, when we do localization ResX style, we typically use bindings to bind localization resources to XAML elements. If we wrap all of that data in something that implements iNotify property changed, we can update those bindings anytime we want to, and we could truly do on-the-fly localization, switching cultures without refreshing the page or resorting to other hacks. This Observable Resources class is going to allow me to do that. Notice it does implement iNotify property changed. It is a generic class because I'm going to use it to wrap the Visual Studio generated Resource Manager wrapper class. And if I want to change the culture on the fly, what I'll do is assign a new culture info object to the current thread. Then I'll call the update bindings method on this localization resources instance. What's magic about update bindings? It causes my localization resources object to fire a property changed event, meaning any bindings that are dependent upon it will automatically update. In other words, the new data from the source will be propagated to the data target. Now, if I'm going to package satellite assemblies containing localization resources and separate zaps, of course I'll need to download those zaps, I'll need to crack them open and load the satellite assemblies. Here's some code that will help me do that. You've already seen this. It's just a zap. We've already demonstrated that we can download a zap, extract the assemblies from it, and load them into the app domain. We're doing the same thing here. We're just doing a little bit of extra work to make sure that the assemblies that we extract are satellite assemblies containing resources and not some other assemblies. So let me go open the first of two demos that's going to help paint a picture of what I just described. I'm going to start by opening one. This too is part of the zip file that comes with this session. And it's called Static Localization Demo. There's nothing dynamic about this one. This just shows how to do localization in Silverlight the same way MSDN shows you how to do it. The way this thing works is pretty simple. When it starts up, it has a simple API with a welcome message, currently shown, I believe, in French, I believe. And you can see the buttons that we can click to change languages are shown in French as well. But I don't read French very well, despite having had several years of it in high school. When you don't get a chance to use it, you kind of forget about it. It's really a shame. One of my goals, by the way, is to speak French really, really well someday. But I think to do it, I'm going to have to come spend 6 months in the country or something like that. But anyway, I'm going to try something here. When I click this Anglais button, that's actually creating a culture info object wrapping the ENUS culture. It's assigning it to the current culture and current UI culture properties of the current thread. In fact, if I were to navigate off to another page right now that is localized, I would see English content. But nothing changed on this main page because this is static localization. Until I refresh these bindings, refresh the page or something, nothing is going to show up on this page in English. Also, if you look at the structure of this project, you'll see that I'm including localization resources for 4 different languages. The default, which for me is English, French, Spanish, and German, or Deutsch. So, right now, from those 4 resources.resx files, Visual Studio is building 3 assemblies named resources.dll. And if you look inside the ZAP, you'll see that indeed they're in there. So even though in this example, the resources are fairly small, we're still making every user pay the price for downloading them. And I would argue that especially in a larger application that contains larger, more complex resources, that is wasteful. So let's fix it. To demonstrate how to fix it, I want to open a separate project named, not that one, named Dynamic Localization Demo. It looks exactly like the previous application on the outside, but on the inside it's quite a bit different. In this example, only the English resources are packaged in the ZAP. If I click one of these buttons for French or for German or for Spanish, I'm going to have to go download another ZAP containing the satellite assembly that I need, then open the ZAP, upload the assembly into the app domain. And because I've also taken the Resource Manager wrapper class that Visual Studio created for me, excuse me, and wrapped it in my own localization resources instance. Remember, that's the class that implements iNotify property change and has that update bindings method. Now, when I click one of these buttons, not only is that satellite assembly being downloaded, if it hasn't already been downloaded before, and being loaded into the app domain, but the content automatically changes, because after creating a new culture info object and assigning it to the current thread, I'm asking my localization resources object instance to update all the data bindings in that page. So, let's take a quick look and see what makes this thing tick. First, you see that there's only one resx file in the main project. This is the one containing my default English resources. I've created a separate Silverlight application project which generates a separate ZAP file named external resources, and that's where I've placed the resource files for German, for Spanish, and French. Now, in real life, I probably wouldn't put 3 of these in one ZAP, because now, if I need one of those, I have to download them all. What I would do in practice is have a separate Silverlight application project, a separate ZAP, for each different satellite assembly, for each set of localization resources, but this still, I think, is enough to prove the point. One other thing that's at play here is that localization or observable resources wrapper class. So, as you know, when I drop a resx file into a project, Visual Studio generates a wrapper class for me that has properties with the same name as my localization resources. In XAML, we data bind to those properties to assign localized content to XAML elements like text blocks, images, and other things. So, this observable resources class here is identical to the one I showed you in the slides. Its job is to wrap that Visual Studio generated class. Through it, I can still access my localization resources by property name, but again, what's key here is that I'm implementing iNotify property changed, so that if I do change the culture info object assigned to the current thread, I can simply call update bindings on this observable resources object to tell it to update all the bindings and change cultures on the fly. I've also built in here a little class named Localization Manager. Now, I haven't made it really robust enough here for real-world use. You'd want to do a little bit of work on it. But it's basically a class that provides a simple API allowing me to change from one culture to another. It's this class that knows which ZAPs have already been downloaded, so it can determine if I want to switch to, say, French, whether it needs to go download the ZAP containing the French culture. It's this class that does the asynchronous download, that loads the satellite assembly into the app domain and things like that. So, if you look inside it, you'll see I'm using a web client to do a download if necessary. You see me creating a new culture info object and changing the culture right here. And then it fires a culture changed event. Over in mainpage.xaml, you'll see me using this. What's actually happening when I click one of those buttons to switch languages is I call change culture on my localization manager instance. I tell it what culture I now want to see. It determines whether a new download needs to be performed and does it if necessary. Then either fires a culture changed event that tell me that it is now assigned a new culture info object to the current thread, and if necessary, downloaded the satellite assembly needed to make that happen, or it fires a culture change failed event if anything goes wrong. Here, using a simple lambda expression, when that culture changed event fires, you see me calling update bindings on the observable resources instance. So not only do we have a means here for factoring the application so that users don't have to download anything more than necessary, but while we're at it, we're able to change cultures on the fly. By the way, this example solves one other problem that I'll bet a lot of you have run into when you're doing localization. When Visual Studio generates that Resource Manager wrapper class, even if you set the visibility of its members to public, it still leaves that class with an internal constructor. That means if I change something in my resources, if I add a new resource or something, after rebuilding or before rebuilding, I have to go back and manually change that internal constructor to public. This effectively hides that. I could change my resources all day long. In fact, I'm compiling and building with an internal public constructor right now, and because I've wrapped it in that observable resources instance, it is totally hidden away. So we've really accomplished three things right here. And if localization is your thing, then I hope that this is helpful to you, because you can generically apply this to a lot of different localization scenarios. All right, let's see what else we can get into. While we're talking about doing things dynamically, what about dynamic page loading? So Silverlight today includes a navigation framework. It was first introduced in Silverlight 3. It was carried over to Silverlight for Windows Phone, and in fact, by default, when you create a new phone application in Visual Studio, that is a navigation application that's being created. What is the navigation framework in Silverlight? First and foremost, it's a means for building multi-page Silverlight applications and for navigating the user between the pages using methods like navigationservice.navigate. Little side note that you may find interesting is that that wasn't the only reason that the Silverlight team added the navigation framework to Silverlight. Back in the Silverlight 2 days, the team was getting a lot of complaints about certain things in Silverlight. One of the big complaints was the back button doesn't work. In a Silverlight application, as I interact with the app and its state is changing, nothing happens with the back button. Same was true of Flash at the time, but the Silverlight team decided that the complaints were so prevalent they needed to do something about them. There was another complaint they were getting quite a lot, and that was the fact that you couldn't deep link into a Silverlight application. That is, as you interact with the app and change its state is not being reflected in the browser's address bar. Therefore, you can't interact with the app, find something you like, take the URL in the browser's address bar and email it off to someone else so that they will say the same thing. The navigation framework was really an answer to all three of those problems. Number one, an easy way to build multi-page Silverlight applications without resorting to some of the hacks we had to resort to in Silverlight 2. A way to enable the back button, because when you call navigationservice.navigate to navigate a user from one page to another, the navigation framework is talking to the browser that's hosting it and adding a node to the browser's history cache. It's also updating what is in the browser's address bar so that we get that deep linking support that we need. In short, the navigation framework has turned out to be probably one of the most important features that have been added to Silverlight. But there is a problem with that framework, or at least a problem with the way we use it. When you build a navigation app that has 4 or 5 or maybe 10 pages in it, no big deal. All those pages are being built into your Zap. But with a small number of pages, you probably don't care. I have seen navigation applications with hundreds of pages, some of those pages very heavy on resources like images. When you're dealing with large, complex applications like that, if you allow all of those pages to be built into the application's Zap file, you are doing your users a disservice. So the question becomes, is there a way to apply what we've learned about loading things dynamically to large navigation applications? In the days of Silverlight 3, the answer was no. The hooks that we needed to make it happen simply weren't there. But in Silverlight 4, the team very quietly added a new interface called iNavigation Content Loader. There's not a whole lot written about it, but it's a very important interface because what it allows you to do is this. It allows you to take control of how pages are loaded as the user navigates from one page to another. I should say where the pages are loaded from. What you do is you build a class that implements the iNavigation Content Loader interface. You register that class with Silverlight, and when that application starts up, each time the user navigates from one page to another, rather than load the page itself by looking to the ZAP file, Silverlight calls out to you via your iNavigation Content Loader and says, load this page for me. Now, you can load that page from wherever you want. You could build the page dynamically on the fly if you wanted to. But what we're going to do is take some of the pages in our application, put them in an external assembly or ZAP, and when that call comes into our iNavigation Content Loader saying, I need this page loaded, we're going to download it asynchronously over the network, load it into the app domain, and now who cares if this application has hundreds or even thousands of pages? We may only put 5 or 10 of them in our ZAP, but the moment we've determined that we need those other ZAPs or assemblies, then we're going to download them. And oh, by the way, we're going to do this in a very generic way so that it becomes very, very simple to do once the code is written. Let me show you what I mean here. First, I do have a couple of slides on the iNavigation Content Loader interface. It is a fairly simple interface. There are just 4 methods. This is what I call a do-nothing content loader because when you plug it in, it basically becomes just a shim. Notice I have a private field here of type Page Resource Content Loader. That is a new runtime class added to Silverlight 4. When you don't provide your own iNavigation Content Loader, it's the runtime's own Page Resource Content Loader that is doing the loading of the pages. And all Page Resource Content Loader really knows how to do is load pages from your application's main ZAP file. What I'm doing in this example is just wrapping my own custom content loader around a Page Resource Content Loader and delegating to it when my methods are called. So other than inserting a shim, I don't really gain anything by doing this, but it does give us a look at what this interface looks like. And one thing you'll notice about it is that it has been designed to be asynchronous from the get-go. That very first method you see there, the begin load method, that is the one that the Silverlight runtime calls when it wants you to load a new page. Notice it's not called load, it's called begin load, and it returns an iasync result. So yes, this infrastructure has been designed to be asynchronous from the ground up, and that's a good thing, because if we are indeed going to go out on the network to download a ZAP or an assembly containing the page that needs to be loaded, we're going to need for all of this to be asynchronous. One last thing I want to show you before we look at some code is this right here. Once you've built the custom content loader, how do you plug it into the application? How do you let Silverlight know it's there? Well, here's what we typically do. We typically create an instance of it declaratively in XAML, as I'm doing here. Of course, you could always create it programmatically if you'd prefer. But then the key is you assign a reference to that instance that has been created to the frame control's content loader property, which was new in Silverlight 4. Then the runtime knows not only that you've provided or that you've implemented iNavigation Content Loader, but you want your implementation to be used by the navigation framework to load those pages. So, let's take a look at some code. After all, when I tell you this stuff, for all you know, I could be making it up, right? If I don't show you code and prove that it works, you should be skeptical of everything that I say. Now, I'll tell you, I haven't told you anything that's untrue today, at least not intentionally. But I have fantasized about perhaps standing in front of a conference audience someday and making up everything that I say just to see who will catch me. As long as I do demos, though, it's going to be pretty hard to get away with that, isn't it? So I want to open a project named Dynamic Navigation Demo for you. And first, I want to show you what it looks like on the outside. It is a 3-page navigation application. When it starts up, we'll see page 1, and we'll see a very simple UI for navigating to the other pages. I can click here, for example, to go to page 2. I'll click here to go to page 3. Click here to go back to page 2, and even go back to page 1. So from the user's perspective, there's nothing special about this app. It just works like any other navigation application does. However, in this example, all is not what it seems. Only page 1 is actually contained inside my application's ZAP file. Pages 2 and 3 are contained in an external DLL, which gets downloaded on demand the first time the user navigates to page 2 or page 3. I'm doing that, of course, with a custom navigation content loader, and I've also gone to some lengths to make it intelligent so that it never downloads an assembly that it has already downloaded. It has to do quite a bit of work internally. For example, here, I hit page 2 before I hit page 3. Remember, they live in the same external assembly. So the moment I hit page 2 for the first time, my navigation content loader pulls down the assembly containing pages 2 and 3. But then, when the user navigates to page 3, I don't want my content loader to go re-download an assembly that's already been downloaded. So it has to recognize when it pulls that assembly down that not only does it contain page 2, it contains page 3 as well. I'm going to open up here in just a moment my code to show you the implementation, but you'll see that I keep a couple of dictionaries sitting in memory. I'm using those for tracking so that my navigation content loader can remember which assemblies it has already downloaded so it can avoid downloading them again, and what types, what pages are in those various assemblies, so that if it's asked to load a page that has not been loaded before but is inside an assembly that has already been downloaded, it can just use reflection to create an instance of the page from that assembly without having to re-download it again. Now there's a little aside here I want to mention to you, by the way. In the big.NET framework, there's a very rich app domain API that allows you to do all sorts of interesting things with app domains. One of the things you can do in the big.NET framework is you can enumerate all of the assemblies that have been loaded into the app domain. There is no way to do that in Silverlight. The app domain API is there in Silverlight, but it's very, very restricted, in part for security reasons. It is impossible in Silverlight today, because Core CLR simply doesn't support it, to walk up to an app domain and say to it what assemblies have been loaded. That's why I have to keep track of some of that stuff myself. The good news is it's not harmful to load an assembly twice. If you had, say, 2 class libraries at work, each of which is downloading assemblies and loading them into the app domain, if they both happen to download and attempt to load the same assembly, the second call to assembly part.load basically becomes a no-op. But I've done what I can here in this content loader to make sure that assemblies are never loaded redundantly, at least to the extent that I'm able to do that. By the way, I'll tell you something that it's not a super secret, but it hasn't been announced either. I actually have permission to say this. The Core CLR team may surprise us in Silverlight 5 with a richer app domain API. You never know what kinds of things might show up there. Then again, they may not. They're very busy people. Okay, let's take a look to see how this thing works. So, I want to look first in main page.xaml where my frame control is declared, because there's something interesting there that you're going to see. I wanted others to be able to take this custom content loader that I wrote and just use it, and use it very easily. So I came up with this magic naming convention. In my URI mapper here assigned to the frame control, I'm mapping each of the pages that my application comprises. But notice this right here, /ext, that means external, followed by colon, followed by the URI, in this case a relative URI, of an assembly. This URI mapping here tells my dynamic content loader that if the user asks to load page2.xaml, that page doesn't exist in the main assembly, but rather exists in an assembly named external pages.dll, which will have to be downloaded automatically if it hasn't been downloaded already. You can see from here that page3.xaml lives in the same assembly. And if this were a much larger, more complex application, maybe I have hundreds of pages divided between dozens of assemblies. With this custom content loader, hooking all that in would be trivial. All I'd have to do is map each page, and through this special /ext extension, designate the assembly that contains it. Now, in fact, if you look at the project itself, you'll find that sitting in the client bin folder, there's not only the zap for the application, but there is that external pages.dll. That is simply a Silverlight class library project. In fact, you see it right down here, and you can see that that's where page 2 and page 3 live. So the real magic comes in here. Notice here in main page.xaml, I'm creating an instance of a class named Dynamic Content Loader. That's my implementation of iNavigation Content Loader, and assigning it to the frames Content Loader property. This, again, tells the runtime that I want to be responsible for loading pages rather than allow the runtime to be responsible for it. The rest is just detail. I won't go through this line for line. You can do that on your own if you want, but this is the code that makes that work. Notice my Dynamic Content Loader class implements the iNavigation Content Loader interface. Here are the two dictionaries I referred to, keeping a list of the assemblies that have already been downloaded and the various types that are found in those assemblies. And then in the begin load method, which is really the heart of this, when I'm asked to load a page, I do a little work. I say, okay, does this page exist in an assembly that has already been downloaded and loaded into the app domain? If so, there's not much I have to do. However, if it exists in an assembly that hasn't already been downloaded and loaded into the app domain, then I'm going to have to launch an asynchronous request to go get it, and in the completion handler do the actual loading. So that is the crux of what is happening here in begin load. You can see here, for example, I'm using create instance. Right here, if this page that's about to be loaded has been loaded before, well, I know the assembly is already in the app domain, so I can use a little bit of reflection just to create another instance of that page. And so on and so forth. There's a little bit of code required to make it work, but all in all, it's less than, what? It's less than 168 lines of code. Not a bad deal considering the kind of efficiency that this lends to a large navigation application. Now, you're probably getting sick of hearing about dynamic this, dynamic that, so let's shift gears just a little bit. I want to introduce something called the behavior. I'm sure a lot of you have used behaviors before, probably some of you have not, but I want to tell you something. I believe that this is possibly the most underrated feature of Silverlight, the most little used. It also, in my experience, has the potential to be the most impactful on your projects. Here's why. Behaviors are a mechanism for packaging up behavior. Hate to use the term again, but behavior as in the noun behavior, the way things act or the way things behave, in a way that a designer working with them in Blend can simply drag and drop them and apply them to UI elements. Now, behaviors are one thing if you're working on a small project with a small team, but at Microsoft, where there's a ton of Silverlight development going on right now, as you can probably imagine, some of the teams are quite large. A lot of these teams are using the MVVM pattern to separate the concerns, break a larger, more complex application down into smaller and more manageable and more testable pieces. But another thing that I've seen that's really, really interesting at Microsoft is that a lot of these teams are divided into two halves. On one half, you have developers, folks who live and breathe Visual Studio and C#. And on the other half of the team, you have designers who, for the most part, aren't coders, although some of them can do some of it. But they're really talented using design tools like Blend to come up with these pretty UIs that developers like me have a hard time building themselves. I've also seen firsthand that how well the designers and the developers collaborate can often make or break a project, because it seems that that's where a lot of the friction comes in. In fact, in some groups at Microsoft, they have a new role, people that they call integrators. Integrators are those rare individuals who have both design skills and coding skills and can look at a project, see where the trouble spots are for the designers and the developers, and up front decide what needs to be done to smooth the process. And very often behaviors, having developers write behaviors to help the designers do the things that are most difficult for designers to do, are the answer to that problem. Now, I'm sure you've never seen developers and designers in a fight, have you? Has anyone ever seen that before? We all just get along, right? I see a hand right here. Yeah, who wins usually? Is it the designers or the developers? Developers, yeah. Developers are a meaner lot, aren't they? Yeah. Designers are artsy people. You know, my daughter is a designer of sorts. She's in high school, and she's really artsy and can draw pretty things out, but I think I could take her in a fist fight. Actually, I don't know if I could, come to think of it. By the way, my daughter is, she's 17 years old. She had her first shooting lesson last week with her Girl Scout troop, believe it or not. I didn't know Girl Scouts went to shooting ranges. So for the first time in my life, my daughter held in her hand a .38 caliber pistol, pointed it at a target, and shot. And in fact, you want to see how she did? Because I just happened to put it on Facebook. I was amazed. Let's see here. If I scroll down just a bit. It's here somewhere, maybe under older posts. Right here. Folks, do not mess with my daughter, especially if she's packing heat. Not bad for someone who's holding a .38 gun in her hand for the very first time, huh? Notice how big those bullet holes are? I doubt I could have done that. I've never shot a .38. Anyway, and for those of you out there who have daughters who are not quite yet teenagers but will be soon, I would highly advise those shooting lessons because it does keep the boys away, and that's a good thing. Now, let's get back to PowerPoint here for just a moment. We were talking about behaviors, weren't we, and about designers and developers. So behaviors, as I said earlier, are, I think, one of the most underrated aspects of Silverlight development. So I want to give you a brief tutorial on behaviors, and I want to show you a couple of ways that they can help you out. Now, first off, writing a behavior, which is something that developers, not designers, do, is basically a matter of deriving from a base class named behavior. In this case, I'm implementing a simple behavior called disappear behavior. Maybe my UI requirements call for certain UI elements to disappear from the scene when they're clicked. And maybe I don't want to impose on my designers the job of writing the logic to make that happen, so I say, you know what, I'm going to write a behavior so that a designer can simply drag and drop that behavior to a UI element on the Blend artboard, and by golly, when that UI element is clicked, it's going to go away. So I write this behavior, this class called disappear behavior. It derives from the behavior T class. By the way, what's significant about the generic parameter passed in there, the T, if you will, is that this makes Blend a little bit smarter. Here I'm saying this behavior can be attached to any UI element, which is basically anything in Silverlight. If, however, I were writing a special behavior that could only apply to layout controls like canvas, stack panel, or grid, I could pass in panel, which is the base class for those layout controls, as the template parameter. And then if a designer in Blend attempted to drop that behavior onto, say, a rectangle rather than a grid, Blend would say, sorry, this behavior can't be attached to a rectangle. Now, when I derive from that behavior base class, I inherit a couple of really important virtual methods named onAttached and onDetaching. The moment the behavior is created and it's attached to a UI element, the onAttached method is called. Your job there is to do whatever it takes to get this behavior up and running to fulfill its mission. In this very simple case here, I want to make the attached UI element go away when it's clicked. So I'm going to need to register a mouse left button down handler so that I'll know when the click occurs. I do that in onAttached. Later on, in onDetaching, if there are any resources that I allocated, any event handlers that I registered, for example, I unwind those there just to make sure that I clean up after myself properly. Then at the very bottom, you can see the onClick handler, or that is the mouse left button down handler, where I make the object that was clicked disappear from the scene simply by setting its visibility property to visibility.collapse. It's a very simple behavior, but it actually does work. And When you apply a behavior to a UI element, typically do this by simply dragging it from the behaviors repository in Blend and drop it onto a UI element on the artboard. This is what the XAML that Blend generates looks like. Notice we're using here an attached property named interaction.behaviors. Blend is declaratively creating an instance of that behavior and attaching it to, in this case, a rectangle. Now, that's a very, very simple example, but let me show you a couple of more realistic examples here. What if I wanted to do this? Let's go back over to Visual Studio. Got about 5 minutes left here. We started a little bit late, so they've given me 5 more minutes of time, by the way. Just so you don't think I'm running over, let's use that 5 minutes to create a couple of applications really quickly. I'm going to call this behavior demo 1, for lack of a better name. And what I'm going to do here just real quickly is let's add some rectangles. How about this? We should be able to do this pretty quickly. What I'll do is first declare a stack panel, set its orientation property to vertical, and then I'll put some rectangles inside it like this. Maybe we'll say width equals, I don't know, 200 and 100. Whoops, not that, but 100. And what else? We'll need to give it a fill property as well. We'll do red, and let's create a couple of, and maybe we'll give it a little margin as well. Maybe a margin of 10. Now let's replicate that thing a couple of times, so that we have a stack of rectangles. And just for good measure, maybe we'll change a couple of the colors here. Blue, how about yellow? What's another color? Green. Purple. I love purple. So we'll add a purple in there as well. So when we run this thing, we'll see that stack of rectangles there, like this. Now, suppose that our UI requirements call for these rectangles to do bubbling mouse overs. That is, when the cursor passes over them, they animate to a larger size. When the cursor leaves them, they animate back to their original size. For a developer, it's not hard to do that kind of thing. We know how to do animations in Silverlight. We know how to write and register mouse event handlers and things like that. For designers, though, it might be a little bit trickier because they don't think in code like we do. However, if we realize that this might pose a bit of a challenge for designers, we could build a behavior that makes that really easy. Now, what I'm going to do here is, in fact, I could just do this in Blend. In fact, let's do it in Blend. I'll just open up the same project in Blend. How about that? Don't know how the help viewer got open. And Blend, where are you? Blend is right here. We'll give it a moment to start up, and we'll open the same project, import some behaviors, and then apply them. I should have started Blend earlier. I may use my remaining 2 minutes 30 seconds for it to start up. Here we go. Well, I spoke too soon. Okay. It's almost there. But it's ignoring me right now. I mean, this is how designers are, right? Okay, here we go. Open project and behavior demo 1. We're going to open in Blend instead of Visual Studio. I thought I did that. Let's see, is it going to appear? Well, am I missing, let's see, in view, what is, where is my artboard? Projects is there. Maybe I just need to open mainpage.xaml. There we go. Let's go over to, boy, somebody's been playing with my Blend workspace. Here we are. Be able to do this. Now I'm trying to figure out how to get into the non-XAML view. Usually there are little angle brackets up here, right? Anybody know? Window? No, that's not what I wanted either. I want to know where the little icons are over here that let you toggle back and forth between the two. Well, Window, reset current workspace. Okay. And where is, you know what I'm talking about? The little angle bracket icon? How do I see this on the artboard rather than in XAML? It's just disappeared, hasn't it? Well, tell you what we'll do. I've got 10 seconds left. We'll just do it in Visual Studio. And it won't let me do the drag and drop thing, but it'll still let me do what I want to do. So let's do this. I'll add a reference, and I'm going to go out and browse and find a sample, an assembly that's in the zip file that goes with this session. And I'll bring it in here because it contains the behaviors that I'm after. Actually, I think I have this under core demos. I do. So let's add a reference to winterlikebehaviors.dll. There are a couple of interesting behaviors in here, one of which is the bubbling mouse over behavior. Now, if I were in Blend, I could see those behaviors over on the left, and I could just drag them down. What we're going to need to do is do what I showed you right here, and to make this really fast, I'll just I'll cut and paste to make this really fast. So let's grab it from there, bring it over here into Visual Studio, do a little bit of fix-up on it. Let's see here. We'll add those in right here. And I'll need to change this namespace to the actual namespace, which will be behavior demo 1. And let's see here. We're getting really, really close. And I'll need to make that all one line. Now I should be able to do here manually what I did in PowerPoint and would have done in Blend if I could have figured out how to get it over into ArtView. I'll just add this and then change the behavior name to each of the rectangles. So right here, we'll split that into starting and an ending tag, paste that in. There is no disappear behavior here. There is, however, not local, but what did I call it? I did call it local. Oh, you know what? What I want here is not that. I want that to be Wintelect behaviors. Wrong key. And I'll also need the assembly. Let's get that right. Get that syntactically correct. Assembly equals should do it. Retrospect, I could have done this, would probably made it a little bit easier. Let's just do it this way. I'm going to have to get that original XML namespace back in there. All right, we're almost there. Now let's find Wintelike behaviors, which should be just a little bit further down. Right there. And now I can just declare instances of the behaviors inside it. So right here, I'll write local, and the one I'm looking for is interesting. Why doesn't it show up there? You know, maybe I shouldn't have even gone into this. It's kind of a rat hole, isn't it? Now let's see. Out of curiosity, is that going to compile? No. Behaviors, property behaviors does not exist on rectangle. Oh, I need a reference to system.windows.NR. You know, the demos in here had gone so well until I started into this. Let me add this reference as well, see if that makes everybody a little bit happier. Should say makes Visual Studio a little bit happier. And let's see, does behaviors don't exist in the type of rectangle, but it should given that I prefix. Oh, gee. So I'll tell you what I'm going to do, folks. Given that we've got another session to start and I'm about 5 minutes over now, look in the zip file. And you will find 2 completed samples that use these behaviors to do bubbling mouse overs on images. And I've got something really cool that you'll like. It's called the magnifier behavior. You just drag it out and drop it onto a canvas. And now when you click the left mouse button over the canvas, a virtual magnifying glass pops up and magnifies everything underneath it. That's probably what I should have done to begin with. Thank you so much, and I apologize for keeping you late.